Have you ever been coding and found yourself copying and pasting the exact same sequence of steps all over the place? Yeah, it's a super common trap to fall into. But there is an incredibly elegant solution. Today, we are diving deep into the template method pattern, a design pattern that's basically a recipe for better, cleaner code. Let's get right into it.
So let's start with a simple question. What do coffee and tea actually have in common? Well, besides being absolutely essential for a developer's survival, the way we make them is surprisingly similar. We're going to follow the story of a little company called Starbucks Coffee to see how this simple observation can lead to some really messy code, and how a simple pattern can come to the rescue.
All right, first up, the caffeine conundrum. Let's explore how having very similar recipes can create a real headache in our code. Okay, just take a look at these two recipes side by side. See it? They are almost identical. Boil water, pour it in a cup. The main steps are exactly the same. The only real differences are the brewing part, brewing coffee versus steeping tea, and what you add at the end. This is a classic sign of code duplication, and trust me, it's a ticking time bomb in any codebase.
So imagine you're coding the Starbucks app. You start with a coffee recipe. You create your methods: boil water, brew coffee grinds, pour in cup, and add sugar and milk. Easy enough, right? And on its own, this code is totally fine. No problems here. But then you get a new requirement: add tea. And look at that. Boil water, pour in cup. It's the same logic all over again. We've just duplicated our code. Now think about this. What happens when the Starbucks boss decides to change how all beverages are poured? You have to remember to change it in two separate places. And that, my friends, is how bugs are born. Yeah, this kind of copy-paste job is a massive red flag in software design. It's a signal, a flashing light, telling us we need to take a step back and really rethink our whole approach. The key is to find what's common and pull it out. Okay, on to our next section, the template for taste. Let's fix this mess by creating one master recipe that rules them all. And here it is, the big aha moment. It's not just that a couple of the steps are the same. The entire algorithm, the whole sequence, is identical. Boil, brew, pour, add. Once you see that, the solution becomes so much clearer. We can build a single, generalized recipe. And this is what that master recipe looks like. See how the boil water and pouring cup steps are concrete? They're always the same. But brew and add condiments, those are flexible placeholders. The master recipe doesn't care how you brew, just that you do brew. Coffee will do it one way, tea will do it another. And what we've just built, this idea of a master recipe with placeholders, well, that's the template method pattern. It's that simple. A parent class defines the skeleton of the algorithm, and the child classes get to fill in the specific, unique details. It's a simple concept, but it is incredibly powerful. I mean, the difference here is just night and day. We've gone from duplicated, scattered code to a single, clean, reusable algorithm. And the best part? Adding a new drink, like, say, hot chocolate, it's a piece of cake now. You just create a new class, implement the unique brew and add condiment steps, and you're done. All right, section 3, hooks in Hollywood. Now let's get a little more advanced. We're going to add some more flexibility and talk about a really cool design principle. Okay, but wait a minute. There's a small problem. What if a customer wants just a plain black coffee? No sugar, no milk. Our current template forces us to add condiments every single time. So how do we handle optional steps? The answer is something called a hook. You can think of it as an optional step in the recipe. The parent class provides a default behavior, like maybe doing nothing, but the child class can choose to override it and do something special. It's a way to let subclasses hook into the algorithm, but only if they need to. This idea of the parent class being in control of the whole process leads us to a really famous concept in software design, famously known as the Hollywood principle. You know the saying, right? Don't call us, we'll call you. That's the whole idea here. The parent class, our caffeine beverage, is the director. It calls all the shots. The child classes, like coffee and tea, are the actors. They don't get to decide when to perform, they just wait for the director to tell them when it's their turn to brew or add condiments. The parent is in control. So let's move on to our final section, patterns in the wild. Let's see where else this pattern pops up, because it's everywhere.
Believe it or not, you have probably used this pattern 1,000 times without even knowing it. Have you ever sorted an array in Java or a similar language? Well, let's say we want to sort an array of ducks, and we want to sort them by their weight. Java's built-in arrays.sort method is a perfect real-world example of the template method.
See, the sort method already knows the sorting algorithm. It's got that part down. But it has absolutely no idea how to compare two ducks. That's our job. We provide the specific logic, usually in a compare to method, and the sort method calls it whenever it needs to make a comparison. It's the Hollywood principle in action. The sort method tells our duck code when to step up and do its thing.
Okay, so let's quickly recap the most important points. The template method pattern defines the skeleton of an algorithm in a superclass and lets the subclasses fill in the blanks. It is all about reusing code and keeping your algorithms consistent. And remember, you can use hooks for optional steps, and the whole thing embodies that "don't call us, we'll call you" Hollywood principle.
So I'll leave you with this final thought. Where in your own code could you use a template to simplify things? Think about those places where you've copied and pasted a sequence of operations. You might be surprised at how much you can clean up. Give it a shot, and happy coding.